On the geometry side, this is all primarily 7th grade material that you should remember. Geometric modeling. So we're going to move towards, we're going to just stretch that volume and surface area component by creating multi-figured objects. So a tree was struck by lightning and its trunk was hollowed. The trunk has a diameter of 6 feet and a height of 10 feet. The center of the tree that was hollowed out has a radius of 2 feet. What is the volume of the remaining tree trunk to the nearest tenth of a foot? So very, very interesting question. So you have this tree and it's been hollowed out, and the trunk has a diameter of 6 feet and a height of 10 feet. So we know that's 10 feet. We know the diameter, so it has a radius of 3 feet. We're going to deal with radii. The center of the tree that was hollowed out has a radius of 2 feet. So it sort of looks like this. It looks like a toilet paper roll. So let's do this. So we know that this distance is 3 feet out to the edge of the tree, and then to the inside of the tree is going to be 2 feet. So that distance is 1, but that's not how we find the volume, because the volume is going to be on that outside. So what we're going to do is we're going to find 2 volumes. The volume of the tree, the physical tree, is going to equal the volume of the outside minus the volume of the inside. So volume of outside is big B times H minus big B times H. The base shape is pi r squared times H minus pi r squared times H. Now we have to keep in mind the radiuses. That's the outside radius. So pi, outside radius is 3 squared times the height is going to be 10 minus pi times the inside radius, which is 2 times 10. So we get 9 pi times 10 minus 4 pi times 10, which is 90 pi minus 40 pi, which gives us 50 pi. So 50 pi feet cubed is going to be the volume. That's, use 3.14 for pi. So they tell us this time that we have to substitute a value for pi. So let's do 50 times 3.14, which gives us 157. 157 feet cubed is going to be our volume. Not bad. So very, very technical one. This is a typical next level when we deal with volume, especially when we deal with like toilet paper stuff. When you have this inside hollowed out, how do you find, actually that's also, how do you find that outside thickness? Well, you have to subtract. You're boring it out. So it's as if you find the whole entire cylinder. So I'll show you quickly. So this volume is going to be the whole entire cylinder. And then we want to subtract this part, this inside cylinder. So we're going to minus that. We're going to subtract that out. It's like a donut. But you got to know it and understand it to really see it. So here we go again. We're going to break this into 2 pieces. So volume, total volume is going to equal the volume of a cylinder plus a volume of a cone. Because that's what we have. We have a cylinder. So volume of cylinder is big B times H. Volume of a cone is 1/3 big B times H. Base area is pi r squared times height plus 1/3. Shape base area of a cone is also going to be pi r squared times your H. So pi times the radius. Radius of my cylinder is 6 times my height is 20 plus 1/3 times pi. Radius again, of my cone is going to be 6 squared. Oh, forgot to square that back there. Times the height. Now the height, here we go again. They make us 6 feet. That is the slant height. We don't want the slant height unless we find the surface area, but we're finding the volume. So we have to do a little side math here. So the leg, or the height squared plus 6 squared is going to equal 10 squared. I think the hypotenuse, that slant height was 10, yep. So h squared plus 36 equals 100 minus 36. H squared equals 64, square root, h equals 8. So my height is going to be 8 feet. So I'm going to multiply that cone, which is a different height than the cylinder, is going to be times 8. All right, so we have pi times 36 times 20, which is 720 pi, plus 1/3 times pi times 36 times 8. That's cross cancel. That's going to be 12. And that's going to be 12 times 8 is 96 pi. So that's going to give us 816 pi. Volume, feet cubed. Again, I think they tell us to use 3.14 for pi. So 816 times 3.14 gives us 2562.24 feet cubed. Does it say to round to the nearest cubic foot? So that's going to be 2562 cubic feet for my volume. 2562 cubic feet. Yeah, good. Warm up, find the area. So here we go. So area of the total, or shaded, is going to equal the area of the square minus the area of the circle. So area of a square is side squared. Circle is pi r squared. The side length is going to be, if this is 4, the other side is going to be 4, because those are radius. So that's going to be 8 squared minus pi. And they want it in terms of pi. Radius is 4 squared. So 64 minus 16 pi would be my area of the shaded. Shaded region is going to be 64 minus 16 pi. Okay. Awesome.